All right, good morning, people, or evening, or whenever you're watching this, really. You can watch it whenever or not right now. This lesson is on Skills D2 and D16 in the Pre-Calculus IXL. We're going to be talking about synthetic division and factoring to find complex solutions. These complex solutions mean real solutions and imaginary solutions. So keep that in mind. I don't know if you remember our imaginary friend I is equal to the square root of -1. And so anytime we have a negative underneath our radical, it's really a -1 and it escapes as I. So keep that in mind. Again, this video is totally optional. You can go into IXL and just try to do the skill, and if it goes fine, fantastic. If you enter in and you're like, I'm not quite sure what to do here, maybe you need a little refresher, maybe you need to watch the video. And of course, your goal is simply an 85 or somewhere around 85. If you get to 90, that would be excellent. If you get higher than 90, wonderful. But I hope that you end up somewhere around 85. And you can stop whenever. If you need to take a break, you can close the program and reopen it and pick up right where you left off. So somewhere in the 85 range is your goal. And once you get that and you're comfortable with your score, then you can stop. I do not expect you to spend hours and hours trying to get 100 on these skills. Beyond 90, it gets quite challenging. We're talking challenges your teacher challenging, and that's really just not necessary for your success in life, okay? All right. Also remember, on IXL, you probably do need to show some work. So whether or not you're using paper and writing stuff down, or maybe you have a whiteboard at home, I created one using a sheet protector and a piece of paper. This is graph paper I just printed from math-aids.com. They have all kinds of different graph paper you can select. And then on the back side, I just have the blank side of the paper, which is great. You can use this to do your IXL practice and erase it, and that's really quite handy. I've been doing it myself when I need to work through some skills too. All right, so here we go, synthetic division. All right, use synthetic division to write the polynomial in q of x plus r over d of x form. That would be q for quotient plus remainder over divisor. I'm not sure if it was r or maybe if it was r of x, whatever your remainder happens to be, but I think it's just going to be a single remainder. Hopefully, we'll see. All right, so we are dividing two polynomials here, and I don't know if you remember synthetic division, but we had this little synthetic division box, and this x minus 3 is the divisor, the thing that is doing the dividing, and this is the dividend. This is the thing that we are dividing into, dividing into, all right? And hopefully we get our quotient out. And if you remember, we write the coefficients of our dividend along the top. And we always want to make sure that we have all of our powers counting down, x squared, x to the first, and this little constant is always x to the 0. So you want to make sure you've got all your powers and you're filling any gaps in with zeros if you have any missing terms. So we're going to put a 1 and a positive 7 and a negative 30 along the top to represent our dividend. And then we're dividing by the polynomial x minus 3. But when we do synthetic division, we need to divide by the 0. So if we take the equation x minus 3 and set it equal to 0, then we would divide. We would use isolate x and get x equals 3, and that 3 is the number we use in synthetic division. It's just one of those things. So always, you bring down your first number, and then we multiply. 1 times 3 is 3, and we combine 7 plus 3 gives you 10. and we multiply. 3 times 10 is 30, and this negative 30 plus 30 is 0. So this is always your remainder. And so then I believe in the answer field, here is our quotient. And this should be our quotient in terms of x. These are just numbers, so we need to backtrack here. When we're doing synthetic division, we are dividing out an x. We're removing an x from what we started with. So x squared divided by x leaves 1 x to the first power. Plus 10 x to the 0 power. And so I think you can just write your 1x plus 10 or just x plus 10 in your answer field, which should be fine. And I imagine the remainder is 0. Even if you put in your remainder of 0 over x minus 3, I actually don't even know if this would work, but you could, this matches the form perfectly. D is for divisor, okay? But we never really write a remainder of 0 divided by anything as 0. So why bother? I think I personally would just leave it like this. Of course, if you had a remainder other than 0, then I would put that up there. All right, here is another way to say the exact same thing. So instead of using the divide symbol, we are literally dividing this polynomial as a fraction. Same thing, means the same thing. So here we have our dividend, and I'm going to go ahead and write my coefficients along the top here. And we have 1x to the 5th, negative 11x to the 4th. Oh, we're missing a term here because we're skipping from 4 down to 2, and that's a no-no. So we have 0x cubed because that one was missing. Then we have 32x squared, and whoops, here we are missing another term again. We went from x squared to x to the 0, so we've got a 0x to the first in there as well. So again, fill in any holes, fill in any missing terms, and then we have 16 for our final constant term. And it does need to go all the way down to 0. If it stopped at 32x squared, then you would have to have plus 0x to the first plus 0x to the 0. So you should really have all of those powers, that's a 2, all of those powers counting down, filling in all the gaps with zeros. Okay, we are dividing by x minus 2, and over here, x minus 2 would be x equals 2. I'm just going to put 2 there. So again, solving for x, we get x equals 2. I'm going to go ahead, bring down my first term, we get 1. We multiply 1 times 2 is 2. We combine, negative 11 plus 2 is negative 9. We multiply 2 and negative 9 is negative 18. Combine, multiply, ooh, getting big here, negative 36. Yeah, that seems right. 32 and a negative 36 is negative 4. Oh, good. Smaller numbers. Negative 4 times 2 is negative 8. Combine, we get negative 8. And multiply, we get negative 16. Hey, look at that. It's a remainder 0 again. How about that? Positive and negative 16 is 0. So here is my quotient. And I'm going to want quotient plus remainder over divisor. We started with x to the 5th. We divided out an x, so this term is going to become x to the 4th. 1x to the 4th minus 9x cubed minus 18x squared minus 4x minus 8. And I think that probably that is a fine answer. If you wanted to put plus 0 over x minus 2, that's probably okay too, but I really think it's unnecessary. I'm not exactly sure what the program is going to say about that. But hopefully those work just fine. I'm surprised both of those had remainders of 0. What a coinkydink. All right, the remainder could be anything. I'm hoping it's just a plain old number like 3 or 12 or 22. Maybe 0 too. All right, hopefully that's a good enough refresher. Now let's look at solving some quadratic form polynomials. List the solutions separated by commas. This is kind of an important part on IXL. You cannot enter in a plus or minus, so you have to separate your answers by using commas. 8x to the fourth minus 64x squared plus 96. Both of these three terms, these are quadratic in form. It's a trinomial. You're going to try to factor. But the other thing I noticed is I know 64 is divided by 8. So I'm looking for the GCF here first. If I can make these numbers smaller, I'd be really happy. 96 divided by 8 is 12. So you know what I'm going to do? Since it's an equation equal to 0, I'm just going to go ahead and divide everything by 8. And that'll make the numbers a lot smaller. 64 divided by 8 is 8. And 96 divided by 8, I just learned, was 12. All right, maybe I knew that before. All right, now we have a trinomial and we can try to factor. What times what is x to the fourth? Oh, x squared times x squared. And then last times last has to be positive 12. What times what is positive 12? 3 and 4, 6 and 2, negative 6 and negative 2. Negative 6 and negative 2. And the reason I chose that, again, check your rainbow, is because when you multiply those outer and inner products, negative 2x squared and negative 6x squared gives us that middle term, which is what we want. Then we can set each bubble equal to 0. All right, and I can go ahead and solve for x. So I'm going to add the 6 to the other side, and then how do you get x by itself? You take a square root. And when you take a square root, you do not forget the plus or minus. So we have plus or minus radical 6. It does say in IXL that you need to simplify any radicals, so you always need to check for perfect squares. And of course, perfect squares are 4, 9, 16, 25, 36, on and on and on. All 2 times 2, 3 times 3, 4 times 4. Look for those perfect squares. This doesn't have any. So it's simplified as far as it can go. And then over here, I'm going to do the same thing. I'm going to move the 2 over and then go ahead and take a square root of both sides. So I get x equals plus or minus radical 2. And again, I can't simplify that. So in IXL, I would put radical 6, comma, negative radical 6. Radical 2, comma, negative radical 2. And it doesn't matter what order you do them in, as long as you have them separated by commas and they're reduced properly. You do need to simplify, and that's the hard part. So check for perfect squares. All right, a couple of times it just said find out complex roots. It didn't really give you an equation, but the idea is pretty much the same here. To find roots, we are simply solving the equation, just like we have been doing. And complex just means that you could get an I in there as well. Complex are real and imaginary things. So down here, these were real solutions. These solutions might have i's involved as well, makes them complex. Looking at these numbers, I do believe I can simplify a little bit. It looks like they all divide by 6. 72 divided by 6 is also 12. So I'm going to go ahead and just divide through by 6. X to the fourth plus 4x squared minus 12 is equal to 0. And just like before, I'm going to go ahead and double bubble. X squared times x squared is x to the fourth. And I need to know what times what is negative 12. Oh, how about a positive 6 and a negative 2? That would give me negative 12. And when I check the rainbow, I'm going to get a positive 4 result. So again, wow, they're the same. Okay. So I'm going to set each bubble equal to 0. That wasn't super helpful. Oh, well, now we can get i's, I guess. Moving that 6, I get a negative 6. And then I'm going to go ahead and take a square root of both sides. So I get x equals, don't forget the plus or minus. And then this one has a negative underneath the radical, which means an I gets to escape, but I can't do anything with 6 right now, so he's going to stay there. My second bubble, x squared equals positive 2, and I can go ahead and square root both sides. Don't forget the plus or minus, so I get plus or minus radical 2, and again, I can't simplify that radical, but numbers like 24 or 12 or 18, those you could all simplify a little bit. So just as a refresher, the square root of 18 is 9 times 2. 9 is a perfect square. So the square root of 9 pops out as a 3, but the 2 stays behind. So just as a reminder, that's how we simplify radicals. In my answer field, I would put I radical 6. There's an I button in IXL. You'll see that little button pop up. You can use the button. If you have a keyboard, you can also just type I. So I radical 6, negative I radical 6, radical 2, and negative radical 2. And those are the answers I would plug into my answer field. All right, hopefully that's good enough. And you should be able to work on skills, pre-calculus skills D2 and D16. Thanks, guys.